Okay, so that's enough about tuning the JVM collectors. I'd now like to talk about choosing which garbage collection algorithm we're going to use. And you might remember that I've made the point quite strongly, I hope, that I've been using Java 8 up until now. And that's because the default garbage collector changed from Java 9 onwards. So I'm going to discuss the pre-Java 9 options first and then talk about what has changed. Now, I'm not going to be giving too much detail about this. I'm going to give you a brief overview of the different types of garbage collector available in the JVM. The virtual machine then has three types of collector called the serial, parallel, and mostly concurrent garbage collector. The serial collector uses a single thread to perform all of the garbage collection work. Now remember that while the garbage collection takes place, your application is paused, so it doesn't matter how many threads are in your application, it doesn't matter if you've got a single threaded or a multiple threaded application, all of your threads are going to be on hold while the garbage collector runs. Now, if your computer is running lots of other applications, then the garbage collector will be competing with those applications for processing time. So I guess if you've got a computer with lots of applications running and not a huge amount of processing power, then your garbage collection process will be slower, certainly than on a computer where no other applications are running. So the serial collector then is using a single thread, and most people's instant reaction is that this is never going to be a good choice. If it's a single threaded collector, it won't run as fast as a multi-threaded collector, so your application's performance is going to suffer as a result. And yes, that will be the case, but there are times when it is a good idea to choose the serial collector. And clearly that's going to be when your application's performance is not the most important thing. Actually, if you're running, say, on a single processor computer and you're running lots of applications and the performance of some other application running on that machine is more important than your application, you may well want to use the serial garbage collector to allow the other application to get the most access to the CPU resources. Actually, the most common use case to use the serial collector is when your Java application is doing some kind of background task. Performance isn't that important, but the server that your application is running on has another application where you are absolutely working to optimize its performance. So you might choose serial when you're wanting to make sure that some other application is getting the best possible opportunities for good performance. To use the serial collector, you provide a runtime argument, which is -xx:+ use serial GC. I don't think we'll bother demonstrating that one. The parallel collector will perform garbage collections on the young generation, and you might remember these are called the minor collections, in parallel. That means you'll have multiple threads running or performing the garbage collection process. So that's going to be a useful option if you have multiple processors on your computer or processors that are able to process multiple threads at the same time, which would be the case, of course, on most modern computers. And this option is normally good for larger datasets also, as it can give better performance than the serial collector. So this collector is sometimes called the Throughput Collector, and you can select this option if it's not your default, and we'll talk about the defaults in a minute, using -xx:+ use parallel GC. So this is, it turns out, the default garbage collector if you're using Java 8 and any of the more modern versions of Java that are 8 or below. And when we've therefore been looking at JVisual VM, actually what we've been seeing is the parallel garbage collector in action. And then finally we have the mostly concurrent collector. Now the Java docs say that this performs most of its work concurrently, and I don't think that's a terribly helpful explanation. The way I understand the mostly concurrent garbage collector works is it's the closest thing we can get to a real-time garbage collection. That is where the application is not paused while the collection process happens. Now that in effect isn't possible. The application does need to be paused, but with the mostly concurrent garbage collector, I think of it that it pauses the application to do the marking of objects, but then resumes the application while the sweep phase takes place. Certainly the idea of a mostly concurrent garbage collector is that the stop the world part of the garbage collection process is going to be minimized. Now, if that explanation isn't complicated enough for you, then I'm pleased to tell you that there are two mostly concurrent garbage collectors that you can choose from, called the Mark Sweep Collector and the G1 collector. And you can choose which of these you are using with the two runtime arguments I'm showing on screen right here. Now, actually, both of these were available in Java 8, but in Java 9, they made the mark sweep collector the default garbage collector. From Java 10, they made G1 the default garbage collector. And actually, although the G1 garbage collector has been present in earlier versions of Java, it has been significantly improved for Java 10, which is why it's now the default garbage collector.